Hello guys, welcome to Self-Help Maths Academy. In continuation of our eigenvalues and eigenvector, let us start with one example where they ask us to find out the eigenvalue and eigenvector of the corresponding matrix A. Okay, so when they ask you to find out the eigenvalue or the eigenvector of a given matrix, then we have to find out first the characteristic equation. Whenever they ask us to find out the eigenvalue, we need a characteristic equation, and for any given matrix A, the characteristic equation is characteristic equation is determinant of A minus lambda I equal to 0. Okay, so this is called as a characteristic equation of any given matrix A. So here if A is any 2 cross 2 matrix, your I also will be a 2 cross 2 matrix, and if it is 3 cross 3 matrix, then I also you should consider as a 3 cross 3 matrix. Alright, so now for this particular example, let us consider the characteristic equation as so here like A minus lambda I, determinant of A minus lambda I is nothing but you will just subtract the lambda from the diagonal values, and remaining values will keep as it is. So I think we have seen this in the previous example, so let me do it directly now. So this is determinant of 2 minus lambda 2 minus 3, this is 2 1 minus lambda minus 6 minus 1 minus 2 0 minus lambda, which is equal to 0. So this is the characteristic equation of the given matrix A. Now let us solve this. We know that solving the determinant for the 3 cross 3 matrix, just taking the alternative sign from the first row I am considering, and then I'll be getting here this as equal to, say, minus 2 minus lambda into let me write it in a bracket, 1 minus lambda into minus lambda, minus into minus plus and another minus, which will be 12 here. Okay, and then minus 2 into 2 into minus lambda, then minus of minus plus again another minus, which is again 6, and then minus 3 into let me take this 3 down here. So minus 3 into we have got minus 4 and plus 1 minus lambda. Yeah, this is equal to 0. Okay, now let us solve this one further. This is equal to minus 2 minus lambda. So this you will get it as minus lambda into 1 is minus lambda into minus lambda, that is equal to lambda square minus 12, and here it is if you see minus 2 and then from here also, from these terms I can take 2 out, which will be like, if I take 2 out, it is simply another negative. I'll also take a negative 2 out, so it will become positive here. So then it will be I left with lambda plus 3 here in the bracket, and then here I have got minus 3 into minus 4 plus 1 is minus 3 and minus lambda, so minus 3 minus lambda, which is equal to 0. Okay, now this is equal to minus 2 minus lambda. So this is like lambda square minus lambda minus minus 12 we have. Okay, and plus 4 into lambda plus 3. From here I'll take minus out, so it will become plus 3 into lambda plus 3, which is equal to 0. Now this term, as we know, let me do it here. So here we have got lambda square minus lambda minus 12. So this one we can write it as, after multiplication I should get negative 12. So and after adding or subtraction it should be negative 1. So simply I can write it as lambda square minus 4 lambda plus 3 lambda minus 12. So this is nothing but lambda, if I take out, it is lambda minus 4, plus 3 if I take out, it is lambda minus 4. So we can write it as lambda minus 4 into lambda plus 3. Okay, so let me write that value here in the, this is equal to minus 2 minus lambda. This one we can write it as minus lambda minus 4 into lambda plus 3, and this is 4 into lambda plus 3, and this is 3 into lambda plus 3, which is equal to 0. Now clearly we have got a terms which here in the first term we have got a lambda minus 3, in the second term we have got a lambda plus 3, and in the third term also we have got a lambda plus 3. So let me take that lambda plus 3 as completely out, okay, and then the remaining terms I'm going to write it in the bracket. Here I have left with minus 2 minus lambda and lambda minus 4 in the first term, and in the second term I've got here 4, and in the third term I've got here 3. Alright, this is equal to 0. Okay, now this is equal to lambda plus 3 into, we can just solve it further. I'll multiply this with lambda again, minus 2 into lambda, minus into minus plus 8, minus into minus minus lambda, minus into plus minus lambda square, and plus 4 lambda. So this is 4 plus 3, which is 7, which is equal to 0. Okay, this is equal to lambda plus 3 into, here I've got minus lambda square, minus 2 lambda minus 4, plus 4 lambda will be plus 2 lambda, 8 plus 7, which is equal to 15, which is equal to 0. Okay, now if you see this one again, let me write for this one here separately. I have got minus lambda square plus 2 lambda plus 15. So after multiplication I should get 15, after addition or subtraction I should get 2. Okay, sorry, negative 15, and that means I can take 5 and 3. Okay, so the plus negative the positive 5 and negative 3, so that will work. The positive 5 and negative 3 if I take, so this here I can take lambda out, so minus lambda plus 5, so minus 3 out if I take, or plus 3 if I take, then it is minus lambda plus 5, so therefore it is minus lambda plus 5 into lambda plus 3. Okay, so now we have got this the fractions here for this. Let me write it here. This is equal to lambda plus 3, this is minus lambda plus 5, and this is lambda plus 3, which is equal to 0. Okay, so from here we have got the lambda value, lambda equal to negative 3. From here also lambda equal to negative 3, so therefore lambda equal to negative 3 is having a multiplicity 2, and minus lambda plus 5 equal to 0 implies lambda is equal to 5. Okay, so lambda is equal to 5. So these are our eigenvalues now. So clearly eigenvalues are lambda equal to negative 3, and 5. Okay, so here since lambda is repeated 2 times, we say that lambda equal to negative 3 is having a multiplicity 2, because it is repeating 2 times. Okay, multiplicity 2, whereas lambda equal to 5 is coming only 1 time, so it is having a multiplicity 1. Okay, so how many times the lambda value will be repeating, the eigenvalue will be repeating, that is called its multiplicity. All right, so now we are good with the eigenvalue. Let's find out the eigenvector. So what is the method to find out the eigenvectors? So we have now 2 eigenvalues, in fact the 3 eigenvalues, but with lambda equal to negative 3 as repeating 2 times. So let's start with for lambda equal to negative 3. What is the steps? How do we do it? Finding the eigenvectors. Okay, so to finding the eigenvectors. So as if you remember, we say that lambda is the eigenvalue only when we can write that as ax equal to lambda x, right? So here my lambda is what? Negative 3. In this case ax will be equal to minus 3 times of x. This is nothing but what? Ax plus 3x is equal to 0. Okay, so this is nothing but what? This implies we can write this as a let me write this, a plus 3 times of I times of x equal to 0. Okay, so this is nothing but, like, if you observe lambda equal to -3 is a eigenvalue, it means it has to satisfy this equation. This is nothing but I'm replacing lambda by -3. This gives you this equation. So whenever you can write this equation, it is nothing but what, if I want to take the x vector here out, so it is simply writing as a plus 3i times of x equal to 0. So this is nothing but, if you see this as a this as a matrix, and with eigenvector is equal to 0, it's a homogeneous equation, right? So it is nothing but, like, a plus 3i augmenting this with 0. So this is what you have to find out usually. This is what is the actual way of doing this, right? So now if I do this with a plus 3i, so as you know, our a is given as, this is our a, this is our matrix A. So let's write it again. So a with 3, it will give me, this will be like this, -2 plus 3, then 2 minus 3, and then 2, this is 1 plus 3 minus 6, then this is -1 minus 2, 0 plus 3. Okay, so just replacing our lambda, if you remember, we have got our lambdas here. So these lambdas I'm replacing with lambda is equal to -3. Okay, so we have got this value. Okay, this is now like, like this. All right, so this is, if you solve it like this, then this will be like 1 2 -3, 2 4 -6, -1 -2 3, and this argument with 0 0 0. Now I'll show you two methods to solve this particular corresponding eigenvectors. One is by using the row transformation. I'll do that, and then I'll show you the other method as well. So here what we do, simply we know that how do we convert the given matrix into reduced echelon form. So use that. So here we have to use the reduced echelon form, that is like R2 changes to R2 minus 2 times of R1, and R3 changes to R3 plus R1. Okay, so this gives us like 1 2 -3 0 0 0, and this is like 2 minus 2 0. So this is 4 minus 4 0, -6 plus 6, which is 0, then -1 plus 1 0, this is 0, this is 0. Okay, so now what we got, we have got this particular equation here. So now let us write this in terms of a solution system, like general solution. How do you write it as? This is with respect to, say, x1 plus 2x2, and this one is like -3x3. This is -3x3 equal to 0, and from second row you have got 0 equal to 0, and from third row also you have got 0 equal to 0. So this implies I'll write our x1 as -2x2 plus 3x3. Okay, x1 we can write this way, and since x2 is free, we can see here there is no pivot position, so x2 is free variable, and x3 is also what? Free variable. Okay, now let me write our x as x1, x2, x3. This is equal to, we have got x1 value as -2x2 plus 3x3, and x2 is free, so write x2 as x2, x3 is free, write x3 as x3. Okay, so this one we can write it as, since this we have to write in terms of x2 and x3, so this will become x2 into -2 1 0 plus x3 into 3 0 1. Okay, 3 0 1. All right, now what we do is, if you see that we have got two free variables, right? We have got x2 into, we have got x3 into. All right, so therefore now if you observe carefully, since lambda equal to -3 is repeating 2 times, we have got a 2 corresponding eigen vectors, this one and this one. Since our lambda equal to -3 was having how many multiplicity? It was having 2 multiplicity. Therefore these the two vectors with let me name it as a v1 I'll take by just giving you different values for x2 and x3, you'll be getting infinitely many values. But I by just taking say x2 as 1 and x3 as 1, I got corresponding eigenvectors as like say 3, 0, 1. Okay, this is one set of eigenvectors which are corresponding to lambda equal to -3. Okay, so these are two eigenvectors. Now we have to find out the eigenvectors for lambda equal to 5. Again for lambda equal to 5, we have to find the eigenvector. Find the eigenvector. So when lambda equal to 5 is the eigenvector, means ax equal to what? It is 5x. This implies what? Ax minus 5x equal to 0. So this implies what? This is nothing but a minus 5I times of x equal to 0. This implies you're solving the augmented matrix what? A minus 5I augmented with 0. This is the I mean, like, you know, matrix we need to solve in order to get the eigenvector. So as we did in the previous, the same method we are continuing. So this will give us we know our matrix. We know our matrix, that is minus 2, 2, minus 3. So just subtract from the in this case when we started here, in this case just lambda, replace it by lambda is equal to 5. Okay, so don't mind, this is my daughter along with me. Minus 2 minus 5, this is 2 minus 3, this is 2, 1 minus 5 minus 6, and then minus 1 minus 2, this is 0 minus 5. Okay, this is 0, 0, 0. Okay, yeah, then you will be getting this as minus 7, 2 minus 3, 2 minus 4 minus 6, minus 1 minus 2 minus 4 minus 5. This we have 0, 0, 0. Okay, now what we do, we'll try to solve it with the same method. What I'll try to do here is, I'll try to interchange my R1 and R3. Okay, because my R3, if you observe, we have got 1 there in the R3, so it is easy for doing a row transformation. So I'll just interchanging them. Okay, this is like 2 minus 4 minus 6, and this is minus 7 minus 2 minus 3. Okay, and then now what we do is like R2 changes to R2 plus R2 changes to R2 plus 2 times of R1 we will do, and R3 also we can change. R3 changes to R3 minus 3 times of 7 times of R3 minus 7 times of R1. Okay, let's do this. So minus 1 minus 2 minus 5. Okay, this is equal to 2 minus 2. This is 2 minus 2, which is 0. We have got minus 4 minus 4, right? Minus 4, that will be equal to minus 8 here. R2 minus 4, that is equal to minus 8. And then we have got minus 6 and minus 10, minus 16, which is 0 here. Okay, and then we have minus 7 plus 7. This will be minus 7 plus 7, which is 0. This is 2 plus 14, right? 2 plus 14, which is 16. And this is minus 3, then plus 35, that is 32. That is 32, which is equal to 0. Okay, all right, we have got this one. So from here, what we can do is, I think from R3, let me do that. So we can, with the help of R2, we can do the R3. So R3 changes to R3 plus 2 times of R1. plus 2 times of r, say 2. Okay, this one we will do. So that what we will get here, we get here minus 1, minus 2, minus 5, this is 0, this is 0, minus 8, minus 16, and this is 0, 16 minus 16, which is 0, 32 minus, this is 0. So here we got a 0. And clearly now from R2 what we can do is that we can take that minus 8, R2 changes to minus 1 over 8 times of R2. Okay, let me do that. We will get, we will get minus 1, minus 2, minus 5, this is 0, 1, 2, 0, so this is 0, 0, 0, 0. Okay, so now we have got the equation. I think we are good to solve here. So let me take one more step in order to do it more precisely. So what I'll do is, with the help of R2 I can make this element 0. So R1 changes to R1 plus 2 times of R2 I will do. So here what I get is, if I do that, then this is minus 1, minus 2 plus 2, which is 0, minus 5 plus 4, which is minus 1. Okay, minus 5 plus 4 is minus 1, 0. So 0, this is 1, this is 2, 0, 0, 0, 0 and 0. Okay, so now let's write this as a solution. If you see, this is like minus x1 and this is minus x3 equal to 0, and from here we write this as x2 plus 2x3 equal to 0, and from here 0 equal to 0 means what? And now what we have here is, we have from the third we have got the x3 as a free variable. So therefore x1 equal to minus x3 and x2 is minus 2x3 and x3 is free. Okay, so therefore let x as x1, x2, x3, this is equal to, so in place of x1 I have got minus x3, x2 is minus 2x3 and x3 is free, so I'll write this as x3. So let me take this x3 out now. This is minus 1, minus 2, 1. Okay, so what we have got this as a vector. This is our vector 3. See, so therefore v3, let me take this v3 as minus 1, minus 2, 1. So this is our eigenvector corresponding to lambda equal to 5. Lambda equal to 5. Okay, so therefore what we have got 3 eigenvalues and 3 eigenvectors. Thus the required eigenvectors are, we have got you have seen here v1 v2 with respect to lambda equal to negative 3, this one minus 2 1 0 3 0 1, minus 2 v1 is minus 2 1 0, v2 is 3 1 0, right? I think we have got 3 0 1, we have got 3 0 1, 3 0 1, and our v3 is equal to minus 1 minus 2 1. Yeah, so these are the 3 eigenvectors which are with respect to the corresponding eigenvalues, lambda equal to 3 and lambda equal to negative 3 and lambda equal to negative 5. Okay, so here this is one such example where we have got the eigenvalues and eigenvector to the corresponding matrix. Okay, so let me take another example. Yeah, this video will be little bigger because the examples will be and also I told you, right, another method as I was talking about. So directly if you consider of solving without actual row transformation, then we have to consider from here itself, you'll be writing all these 3 equations in terms of the like x1 plus 2x2 minus 3x3 equal to 0, and like that, and then you'll be solving it simultaneously, and then you will write the equation for x1 x2 x3. Okay, but I feel that this particular method will be quite easy for you all, because you know already the row transformation. Okay, so therefore please remember what steps we're using. I think maybe another example will help us to find check how do we go for the eigen value, okay, and eigenvector. So let me take another example. uh, so the example goes like this. Let me start with the example. Let the matrix A here is 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. Okay, we have to find out the eigenvalue and corresponding eigenvectors for this particular matrix. So as I told you, to find out any eigenvalue and eigenvectors, what we have to find out first, we have to find out the characteristic equation for a given matrix. So the characteristic equation of this particular matrix is determinant of A minus lambda I equal to 0. Okay, so in this case, determinant of A minus lambda I will be equal to what? 8 minus lambda. So just subtract from the diagonal entries. So 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4. So 2 minus 4 3 minus lambda, which is equal to 0. Okay, now solve it with plus plus minus plus sign, and this we will get it as, okay. Let's see how do we solve this one. Here we'll be getting 8 minus lambda into, this is 7 minus lambda 3 minus lambda, then minus into minus plus another minus, that is 16 here. Then this is minus of minus plus 6 into minus 6 into 3 minus lambda. This is minus 8, which is plus 8. Okay, then plus 2 into, we have got 24 minus 2 into 7 minus lambda. This is equal to 0. Okay, yes, this is what we have got. Now let us solve it further. This is 8 minus lambda into, so 7 times of 3, that is 21, minus 7 lambda minus 3 lambda plus lambda square minus 16. So this is plus 6 into, okay, minus 18 plus 6 lambda plus 8. Okay, then plus 2 into 24 minus 14 plus 2 lambda, which is equal to 0. Okay, so here solving further, so 8 minus lambda, this is lambda square minus 7 minus 3, that is minus 10 lambda. So 21 minus 16, we have got plus 5 here. Okay, yeah, this is like, yeah, this is what we have got, plus 5 here. Then plus 6 into 6 lambda minus 18 plus 8, that will be 10, minus 10 plus 2 into 10 plus 2 lambda, this is equal to 0. Okay, yeah, now let's solve it further. What we have got is like simplifying. If I multiply this inside, I'll get here 8 lambda square minus 80 lambda plus 40, then with negative lambda inside, so this is negative lambda cube plus 10 lambda square minus 5 lambda plus 36 lambda minus 60, then plus 20 plus 4 lambda, which is equal to 0. Okay, yeah, now further you solve it. This is minus lambda cube here, minus lambda cube here, 8 lambda square we have, and 10 lambda square, which is 18 lambda square. Okay, 18 lambda square. Yeah, then we have got plus 40, then plus 20, which is plus 60, and here we have got minus 60. Let us cancel this. Let us cancel this. So this is minus lambda square. Then what we have got, what we have left with, 18 lambda square, 18 lambda square plus we have got minus 36 lambda, then we have got 85 lambda here, minus 85, and 36, right? So 49 plus 4 lambda, that will be equal to 45 lambda. Okay, so here we have got minus 45 lambda. Okay, we have got minus 45 lambda, which is equal to 0. So clearly we have got lambda, we can take out. Okay, let me take minus lambda out. This will become lambda square minus 18 lambda plus 45, which is equal to 0. Okay, since this implies minus lambda equal to 0 means lambda equal to 0, we can consider one of the eigenvalue we have got. So here we have got this equation. So let me this is a quadratic equation, so let us solve this. We have got lambda square minus 18 lambda plus 45 equal to 0. Okay, so after multiplication I should get 45, and after addition or subtraction I should get 18. So I think minus 15 and minus 3 will do. So let us write this as lambda square minus 15 lambda minus 3 lambda plus 45 equal to 0. So from here we got lambda out, so lambda minus 15. So from here we can take out 3, so it is lambda minus 15. So here we have got a factors as lambda minus 15 and lambda minus 3, which is equal to 0. So clearly from here we got lambda equal to 15 and lambda equal to 3. So hence we have got three eigenvalues, that is lambda equal to 0, 3 and 15. So these are the three eigenvalues we have got corresponding to the matrix A. Okay, now we have to find out the corresponding eigenvectors, right? So this is if you see this particular solution, it may looks big, but please be careful with the signs here when you are solving all the eigenvalues. Okay, be careful with the signs and the multiplication and addition and subtraction when you're doing, and you can solve the like characteristic equation properly, and you'll be getting the required answer for the eigenvalues. Because once the eigenvalues are wrong, then the corresponding eigenvectors also will be wrong. That's why we have to be very careful and very clear when you're solving them. All right, so now let me take one by one. The case 1, that is when lambda equal to 0, what will be the eigenvector. So we know that Ax should be equal to lambda x. That should be our equation, right, for finding out the eigenvector. So here lambda is 0, so this will become what? Ax equal to 0 times of x, or it is simply Ax minus 0 times of x, which is equal to 0, implies it is simply like a we are augmenting with 0. All right, so this is the meaning. Okay, so just consider the required given matrix and take the augmentation with 0. So that will be like you'll be getting here 8 minus 6 plus 2, this is a minus 6, 7 minus 4, and here you have got 2 minus 4, 3, then augmenting this with 0, 0, 0. Okay, yeah. Now let's do the row transformation. As you know, we can solve this by using the row operation. So let me interchange R1 and R3. Okay, R1 and R3 I'm interchanging. Let me take this as 2 minus 4, 3. Then let me write this as 0. So minus 6, 7 minus 4, 0. So this is 8 minus 6, 2, 0. Yeah. Now since here we have got 2, here we have got 8, our R2 we will change as R2. See here you have got 6 here. So R2 plus, if I multiply this with 3 times of R1, so minus 6 plus 6 will become 0. Similarly, R3 changes to, here we have got 8, here we have got 2. So this will be like R3 minus 4 times of, if I write here 4 times of say R1, then I will get 0. Okay, so let us do those operations here. This will be, as I am not doing any changes in the R1, I am keeping this as it is. So this is 0 minus 6 plus 6. Here we have got 7 minus 12, right? Minus 4 times of 3 will be 12. So 7 minus 12 will give you minus 5. So this is minus 4 plus 9. Minus 4 plus 9, that is 5 again. So this is 8 minus 8, which is 0. This is minus 6 plus 16. Okay, minus 6 minus of minus 4 plus 16, that will be 9. Okay, and then 2 minus of minus 12, 2 minus 12, right? That will be 2 minus 12, which is equal to minus 10, that is equal to 0. Okay, yeah, this is what we got. And from here I think we are good with the calculations. I think we have to be fine here. Let's see. Okay, now what I do is from R2 let me take this minus 1 by 5. Okay, so this is 2 minus 4 3 0 0 1 minus 1 0. So 0 9 minus 10 0. Okay, so here with the help of R2, let me make the R3 0. So what I do here is R3 changes to R3 minus 9 times of R2. Okay, let us see what we get here. So from here 2 minus 4 3 0. Just you can reduce it up to the Gauss elimination method, that is also fine to solve it further. This is like 0 9 minus 9 0. Here we have got minus 10 and this is like minus 9. Okay, minus 10 minus 9, minus 10 plus 9, because minus of minus 9, that will be plus 9. So that will be your negative 1 0. So I think now we are here. Okay, so let's write it as a solution from here itself. Okay, now let me write this as 2x1 minus 4x2 plus 3x3 equal to 0. And from here we got x2 minus x3 equal to 0. And from this we have got minus x3 equal to 0 implies what? X3 equal to 0. Okay, we have got x3 value as 0 here. All right, so here let me write here. Okay, now here we have got x3 equal to 0, and let us write from here. When I got x3 equal to 0, if I put it here, it also implies your x2 equal to 0. Okay, and then if x2 and x3 are 0, your x1 also will be 0. Right, so we have got, let's say, x as x1 x2 x3. Then we have got x1 value as say 0 0 0. Okay, so this is one of the corresponding eigenvector we have got. Let me see for lambda equal to. For lambda equal to, we have got 3. For lambda equal to 3, we will take this as 8 minus 3 minus 6 2, and then minus 6 7 minus 3 minus 4, and we have got 2 minus 4 3 minus 3. Okay, this is 0 0 0. Okay, let us solve this. We will get here 5 minus 6 2 0. This is minus 6 4 minus 4 0 2 minus 4 0 0. Okay, yeah, now let us solve this also with the row transformation. Now for the better, let me write this as r2 changes to, directly we can do, or we can interchange the r1 and r3. So let me interchange r1 and r3. This will give us, 2 minus 4 0 0, and minus 6 4 minus 4 0, 5 minus 6 2 0. Okay, yes. And from r1 I can take 1 by 2 out to make it as simply 1, minus 2 0 0. And if we want also from r2 we can take, not required, but still if you want you can take it as minus 1 by 2 times of r2, which gives you 3 minus 2 2 0. This is simply minus 5 6 2 0. Okay, just for easy calculations. Now let me use the row operations. r2 changes to r2 minus 3 times of r1, and r3 changes to r3 minus 5 times of r1. Okay, let's see. This we get it as 1 minus 2 0 0. This is 3 minus 3, which is 0. Then minus 2 plus 6, which is 4. Okay, then 2, which is simply 2 here, 0. And here we have got 5 minus 5, which is 0. Minus 6 plus 10, right? Yeah, this will be 4 here, and 2, which is simply 2. Okay, yeah. Now simply what we do from r3 changes to r3 minus r2 we will do. So this is 1 minus 2 0 0 0 4 2 0 0 0 0 0. Okay, so clearly from this we have got our x3 as free variable. So let us write the solution as x1 minus 2x2 equal to 0, and we have got here 4x2 plus 2x3 equal to 0. And from here we know that our x2 is minus 2x3 upon 4, which is simply x2 equal to minus 1 by 2 times of x3. So we can substitute this value from x2 value in the first equation. So we get x1 equal to 2x2. So this is equal to 2 into minus 1 by 2 times of x3. This we can cancel. Here we get minus x3. Okay, so therefore when you write a solution x as, it is x1 x2 x3, your x1 is 2x2, x1 is minus x3, and x2 is minus 1 by 2 times of x3, and x3 is free. So therefore x3 into, we get here minus 1 minus 1 minus 1 by 2 and 1. Okay, so this is our corresponding eigenvector. So I think I'll leave similarly for lambda equal to 15 for you guys. Lambda equal to for 15, yeah, you will be having this particular matrix. I will write it for you, and I also write a solutions for you. Please check and verify your answers. So for lambda equal to 15, you will be getting the matrix as 8 minus 15 minus 6 2 0, and you'll be getting minus 6 7 minus 15 minus 4 0, and then you'll be having 2 minus 4 3 minus 15 0. Okay, so this, after doing all the row transformation and finding the final answer I'm writing, you guys have to solve it and comment in the box if you're getting the correct answers or you're getting a different answers. Okay, so you'll be getting here x3 into 2 minus 2 1. Okay, so this is your corresponding eigenvectors you're getting with respect to lambda equal to 15. So we have got the 3 eigenvalues and corresponding eigenvectors. Okay, so these steps will be little lengthy, but you guys, when you solve more examples, I think you'll become familiar with the problems. Okay, so this is how we will be solving the eigenvalues and corresponding eigenvectors for a given problem. Okay, I think one problem I'll be posting it here for you. Just check in case if a is given as, say, 4 minus 1 6, 2 1 6 and 2 minus 1 8. Okay, this is a given matrix. uh, Here they are given you that let A is having an eigenvalue as lambda equal to 2. Find the corresponding eigenvector. They may ask you eigenvector, or they may ask you to find out the basis for the corresponding eigenspace. Okay, both are same. Find the basis for the eigenspace means find out the corresponding eigenvector for this lambda equal to 2. Okay, so solve this and comment the answers in the box. Okay, then with this let us conclude today's discussion, guys. Maybe in the next video we will we will discuss about some more different variety of examples and some of the properties with respect to the eigenvalues. Okay, till then, take care, guys.